Welcome back. In this session, we are going to discuss a topic called long data filtering. Under long data filtering, we have to discuss two methods of long data filtering. One is called overlap and add method, and second is called overlap and save method. So we'll discuss them one by one. So the first question is, what is long data, or rather what is long data filtering? Consider a system whose impulse response is h of n and the input is x of n. When the system processes this input get convolved with the impulse response, and to get output yn you have to convolve input and impulse response. What will happen if the length of this x of n is very large? Then this convolution of x of n with h of n become very tedious, because the length of x of n is very large, and hence we have to discuss a method by which we can filter out this h of n, because this convolution is called a filtering operation. So this filtering can be done by dividing x of n into some blocks. So we have to divide this x of n into some sections or blocks and perform the convolution. So in order to understand this, consider a sequence x of n whose samples are, say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and second section signal is h of n is 1, 1, 1. Here I say that length of the input sequence is 10 and length of impulse response is 3. So length of x is larger than length of h. So comparatively I can say that the impulse response is very small and length of the input signal is large. So I say that Lx is 10. Actually it is not large enough, but for understanding purpose we assume that this length is very large. So while solving the example based on this, we assume that this length is large. Actually it is not, but for only understanding we say that this length is very large. If we don't assume this length to be large, we could have obtained the convolution directly like this. Already in signal systems we had discussed sum of column method, how to convolve x of n with h of n. You write the first sequence and you write second sequence, then you multiply this number with this number. So 1 into 1 is 1, 1 into 2 is 2, 1 into 3 is 3, 1 into 4 is 4, and so on. Then we put a dash here, then this 1 into 1 is 1, 1 into 2 is 2, 1 into 3 is 3, and so on. Then we multiply this 1 into 1 is 1 here, we put 2 dash here, and so on. So this way we could have obtained the numbers, and then we have summed these numbers. 1 plus dash, that is 1, 2 plus 1 is 3, 3 plus 2 plus 1 is 6, 4 plus 3 7, 7 plus 2 9, and so on, and I could have got this answer. Those who remember this method can use this method to verify your answer, or alternately in signal systems we also discuss this matrix method, how to convert two sequences. You write the first sequence as a column, second number as a row, and then you multiply every number with other number. 1 into 1 is 1, 1 into 2 is 2, 1 into 3 is 3, 1 into 4 is 4, and so on. And then you obtain this cross sum: 1, 2 plus 1, 3, 3 plus 2 plus 1, that is 6, 4 plus 3, 7, 7 plus 2, 9 here, 5 plus 4, 9, 9 plus 3, 12 here, 6 plus 4, 10, 10 plus 5, 15, and so on. So this way also I could have got the answer. So the same answer I have to obtain using this overlap and add method and overlap and save method, and we'll verify after performing or after going through those methods. So we have to discuss this sectional convolution method. I call them sectional method because we have to divide x of n into blocks. So we have to divide x of n into some sections or block and then perform convolution. This answer you have to remember, because this answer will eventually we'll get when we solve the same example using overlap and add method and overlap and save method. Let us discuss first of all overlap and add method. So I'll say it is overlap and add method. So we'll start with our sequence x of n. We assume that this is a very lengthy sequence. Actually not, but we assume that this is very long sequence, and h of n is here in our case it is 1 1 1. So when you start doing this sectional convolution called overlap and add method, in step number 1 is you make sections. You make sections of some suitable length. So let us make some sections of x of n of suitable length. Let's say section length is, or the block size is, say 4. So we'll divide this x of n into some blocks, and we have first block equal to 1 2 3 4. Second block is 5 6 7 8. Third block is 9 10. Then we don't have any number, so I should say 0 0. Okay, so step number 2, note the length of x every block, length of x1, length of x2, length of x3, and so on. It is 4. And length of h is here of length 3, so I'll say LH is 3. So you say that you make length of all blocks of length 4 plus 3 minus 1. So length of every block is 4, length of impulse response is 3, so 4 plus 3 7, 7 minus 1 is 6. So you have to make length of all blocks of length 6 by 0 padding. So what is 0 padding? I'll say x1n, x1p after 0 padding becomes 1 2 3 4, followed by 2 zeros, these are the zero padded sequence. So insert 2 extra zeros to make the sequence of length 6. Second sequence now will become 5 6 7 8 followed by 2 zeros. X3p will become 9 10 0 0 0 0, and again you have to zero pad the impulse response to have again the same length. So this is the second step. Third step is you convolve, or in fact you perform circular convolution of x1p. So I'll say x1p, the zero padded sequence that we got in last step has to be convolved with hpn, again convolve x2p, with h of n, and so on. So let us perform circular convolution of these two sequences. So to perform this circular convolution, I will use matrix method of circular convolution. So let us convolve 1 2 3 4 0 0. It has to be circularly convolved with 1 1 1 1 followed by 3 zeros. So you have to create a circulant matrix of size 6 by 6. So what you have to do, choose any sequence. I'll choose 1 2 3 only, 1 2 3 1 2 3 4 0 0. So write these numbers in a first column, then shift this 0 at the top, then shift every number by one position down. So 3 here, 4 here, 4 here, and 0 here. Again 0 top, 1 here, sorry 0 here. This 0 shifted, 1 is shifted, 2 is shifted, 3 is shifted, 4 is shifted. Then this 0 at the top. I think we should write it once again. One, 2, 3, 4, 0, 0. So 0 at the top. Then 1, 2, 3, 4, 0. Then 0 at the top. This 0 goes to the top. And then you have to shift every number by one position. So this 0 goes at the top next time. So this is 0, 1, 2, 3, 4. Then this 4 goes on top. Then shift every number by one row. 0, 0, 1, 2, 3. Then 3 at the top. 0, sorry 4. 0, 0, 1, 0, 0, 1, 2, 2 at the top. 3 4 0 0 1. So we have to stop here because the matrix of size 6 by 6 we have got it. Then this matrix you have to multiply it by the other matrix 1 1 1 followed by 3 zeros. So now perform the matrix multiplication, first row into first column. Here I can say that you have to just sum the first three numbers because last three numbers are 0. So when you multiply row with column, you have to perform addition of 1 plus 0 plus 0, it is 1. Second row, first column gives me 2 plus 1 plus 0, that is 3. 3 plus 2 plus 1 gives me 6. 4 plus 7, 4 plus 3, 7, 7 plus 2, 9. 9 will come here. 0 plus 4 plus 3 gives me 7, and 0 plus 0 plus 4 gives me 4. So the first result we have got is 136,974. Similarly, we have to obtain the second result. Second result, so that is circular convolution of X2P with HPN. We had X2P as 5 6 7 8 followed by 2 zeros. You have to convolve it to a circularly convolve with 1 1 1 followed by 3 zeros. So let us again draw that circular matrix. Multiplied by 1 1 1, and this will give me 5 plus 0 plus 0, that is 5. 6 plus 5, 11. 7 plus 6 plus 5, 18. 8 plus 7 plus 6 21. 0 plus 8 plus 7, 15, and 0 plus 0 plus 8 is 8. So this second result I write here: 5, 11, 18, 21, 15, 8. Perform the third convolution, circular convolution. X3n circular convolved with HPN. Here it is 0 paired sequence. It should be 9, 10, 1, 2, 3, 4 zeros, then 0 here, 9, 10, 0, 0, 0, 0 at the top, 0, 9, 10, 0, 0, 0 at the top, 0, 0, 9, 10, 0, 0 at the top, 0, 0, 0, 9, 10, 10 at the top, 0, 0, 0, 0, 9. And then you have to perform this matrix multiplication. Now this is 9 plus 0 plus 0, that is 9. 10 plus 9, 19. 0 plus 10 plus 9, again 19. 0 plus 0 plus 10 is 10. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. So this answer comes out to be 9, 19, 19, 10, 0, 0. Now this is, I think, third step. Now we'll go to the step number 4. Add the all earlier result with an shift of 4. See here, the first sequence you have to write as it is. So this first result I will write as it is, 136974. So 136974 you have to write as it is. Then while adding second result, you have to add a shift of 4. So add the second result to first result with a shift of 4. And the second result, we know that it is 5, 11, 18, 21, 15 and 8. So I have copied this result, 5, 11, 18, 21, 15, 8. And the third result, while you adding, you have to add a shift of 8. 1, 2, 3, 4, 5, 6, 7, 8. Because we have with shift of, I can say 0, 4 and so on. So you have to add all results with the shift of 0, 4 and so on, 4, 8 and so on, because we had chosen the length of the block size to be 4. So depending upon the block size, you have to add shift. So second block starts with a shift of 4 and the third block starts after a shift of 8. Hence we have to add a shift, we have to shift the third result by 8 units, and then you have to write 9, 19, again 19, 10 0 0, and this all result now you have to sum. 1 3 6 9 12 15 18 21 24 27 19 10 and 0. So this is the same result that we have obtained. Just verify this from the earlier step. 1 3 6 9 12 15. 1 3 6 9 12 15 18 21 24 27 27 and 27 followed by 19 and then 10. And the same answer we have got here. So with this we'll stop here.